Welcome, ladies and gentlemen. Let's go ahead and solve our compound inequalities for today's Bellwork. We know that we can solve a compound inequality, right, in the same way that we solve equations, using the same inverse operations. The only difference is when we multiply or divide both sides by a negative number, then we have to change the direction of our inequality symbol. So sometimes we'll have to do that, sometimes we won't. What are we on the lookout for? If we multiply or divide both sides of the inequality by a negative, that's the only time when we have to do something different than solving a regular equation. We'll reverse the direction of the symbol. So let's go ahead and solve each of these components in my OR type compound inequality separately, and then put them on the same number line graph. So here we go. Solving that first one, looks like we can use the same inverse operation we would to solve an equation. I'll subtract 5 from both sides of the inequality. We'll go ahead and bring down my x over 3. It looks like subtraction doesn't change any inequality symbol, so this is still a less than or equal to. 4 minus 5 is negative 1. We'll go ahead and solve for x in one last inverse operation. It looks like we'll multiply both sides by 3. Multiplying by 3, we'll get my x alone. And negative 1 times 3 is negative 3. The only question is, what about the symbol? Do we have to reverse the direction? Well, we did have a negative 1 here, but am I going to have to change the direction of my symbol as a result? Kelsey?
No.
No?
That's positive.
Absolutely. We multiply both sides by a positive 3. It didn't matter what number was here. This negative 1 has no impact on the direction of my symbol. It's just the inverse operation that I'm performing to both sides. If I multiply or divide both sides of an inequality by a negative, that's when I have to change the direction. Here we multiply both sides by that positive 3, so we don't have to change the direction. This is still a less than or equal to negative 3. Meanwhile, back at the hacienda, we still have to solve my right-hand side. And so to solve this right-hand side, we'll use our same inverse operations. It looks like the best first step is going to be subtract 3 from both sides. That'll get my x term alone on one side. Negative x is less than, and then 1 minus 3 is negative 2. And now I need to multiply both sides by a negative 1 or divide both sides by a negative 1. Either one is fine to get that x variable by itself. So when I divide both sides, flashing red lights, sirens going off, that's when I need to, patent pending, reverse the direction of my inequality symbol because I divided both sides by a negative number. So now this becomes a greater than symbol. So I've isolated x. Negative divided by negative is still a positive, right? All my inverse operations are the same. It's just that if I multiply or divide both sides by a negative number, right, then I need to reverse the direction of my inequality symbol. All right, let's put it all together. My solutions x are less than or equal to negative 3 or are greater than positive 2. So how do we make our graph? We'll go to our number line. We'll find our boundary number. In this case, negative 3. Label it. If it's or equal to, we'll make it a closed circle and shade everywhere to the left in the case of less than. Or find my boundary number, in this case 2. Don't fill it in. Leave it as an open circle because it was a strictly the solution x equals 2 is not a part of my solution set. And then shade everywhere to the right because this was x greater than points up the number line. Go ahead and raise your hand if you had x less than or equal to negative 3 or x greater than 2. Did you get the symbol direction right? Way to go, you guys. Excellent. Everybody think of your favorite solution to number 1 then. You can pick it out from the shaded region or you can choose one based on the algebraic expression. What's your favorite solution to number 1? Katie?
Negative 2.
Negative 2?
Oh, negative 4.
Negative 4, absolutely. Negative 4 is in my shaded region. Thank you. Lucas?
Negative 3.
Negative 3, that is a or equal to, it's a closed circle. It is included as part of my solution set. Good. Give me a different solution. Jaden? 5, absolutely. And so we can look multiple places if we're dealing with an inequality. And if it's an OR type, I can look typically to the left of one number or to the right of another number. So you've got 2 different places where you can look, and that's kind of signature for an OR type compound inequality. Awesome. What questions do you guys have at number 1? Let's take a look at number 2. Is this an OR type compound inequality? No, when connected by a string, right? All in a line, this is an AND type compound inequality. where typically my solutions fall in between one number and another, right? And so let's go ahead and see if we can solve this. Algebraically, I'm going to do the same inverse operations as if I were solving an equation. It's just that we're going to do it to all three columns here. So my best first step, subtract 3. It's just we're going to do it to all three columns. Negative 5 minus 3 is negative 8. 3 minus 3 is 0, and I isolate my x term. And 7 minus 3 is 4. Do I need to change the direction of my symbol? No, I was adding or subtracting, and I never changed the direction of my inequality symbol as a result of addition or subtraction. So I'll leave that as a less than or equal to, and I'll leave that as a strictly less than. Next, I'm going to go ahead and solve for x by dividing both sides. Well, looks like all three columns rather by negative 2. That's going to get x alone. There's my flashing red lights, my waving red flags. It looks to me like I've divided by a negative number, right? And then I need to reverse the direction of my inequality symbols. And so it's not just this one, but it's this one too. So this less than or equal to becomes a greater than or equal to. This less than becomes a greater than. And I can fill in now. Negative divided by negative is positive. X and positive divided by negative is negative. So it looks to me like we're good to go. If we reorder, right, if we reorder our inequality so that we have the leftmost side of my window written first, then we're following good mathematics. We always want to make sure the leftmost side of my solution set is all the way over on the left-hand side. So this becomes negative 2 is less than my solutions x, which are less than or equal to 4 in a final reorder, and now I'm ready to make the graph. So how do we do that? Go to our boundary numbers. Negative 2, label it. 4, label it. The negative 2 is strictly, so we don't include it. It's an open circle. The positive 4 is or equal to, so we do include it, and we show that with a closed circle. And where are we going to shade? Well, it's easy to see in my algebraic statement. My solutions x are in between negative 2 and 4, so I'm going to shade in between negative 2 and 4. Everybody pick out your favorite solution number 2 and share with the class when I call on you. So what's the solution to this compound inequality, the and type? Ellen?
0.
0, right? That's in my shaded region. Nathan? 4. That's in my shaded region because it's or equal to. We do include it. What about negative 2? No, negative 2 is a strictly, so we do not include it. Nice job. What questions do you guys have about number 2? Okay, I'm going to go ahead and pause the recording and we'll take care of our homework check, okay? Today we're going to discuss our activity number 2 question to make sure you're comfortable with the astronaut problem. Then we're going to go ahead and outline our stamp count for Unit 7 and have some structured review time as you work and prepare for your Unit 7 test. Remember that test is next class, okay? Next class. So let's go ahead and take a look at our linear programming activity number 2. This was the astronaut question where we had to determine the optimal combination of food bars and drink cartons that would make sure you keep your astronaut healthy and alive, right? And so we could let x be the number of food bars you're going to bring into space. And we could let y equal the number of drink cartons. We then have a grams of fat constraint, a grams of carbohydrate constraint, and a grams of protein constraint. We need at least 61 grams of fat to keep our astronaut healthy. We need at least 350 carbs, right? Carbohydrate grams to keep our astronaut healthy, and we need at least 103 grams of protein. So after translating, we get each of those 3 constraints, and I already checked this along with your objective function for your 4 stamp. So you guys did a great job with that. Our objective equation then was not maximize profit P equals, or maximize the number of exhibits, like in your linear programming number 2. E equals, rather it was to minimize the weight. You want to minimize the weight that you have to carry up in your spaceship, right? So that you can blast out of the orbit with your rocket. So we wanted to minimize weight. We wrote a W equals objective function, and you guys did a nice job with that. Next, we went ahead and graphed our constraints on the same XY axis. And so if our x-axis is the food bars, and y-axis is the drink cartons, graphing our grams fat, our grams carbohydrate, and our grams protein, results in the feasible region that now bigger than each of those boundary lines, greater than. And so this was a case where my feasible region lay above those boundary lines. In order to determine my critical points, right, I had to solve some systems. And so if I wanted to solve for this critical point, I'd write a system of the blue equation and the green equation and go off and solve that. If I wanted to solve for this critical point, I'd write a different system, and that would be with the red equation and the green equation only, and I'd solve for that in my margin. After doing so, I created the critical points 0, 14, 5, 6, 11, 1, and 13, 0. Notice how we had to do some, right, if you had to do some rounding, depending upon what you calculated, you want to make sure that you satisfy the minimum nutritional requirements. And so if you got something like, right, if you got something like 10.2, right, you'd have to round that up to 11 to make sure that you're getting enough protein or fat or carbohydrate grams. So this is a situation where, in context, you have to think what makes the most sense to satisfy those nutritional requirements. In any case, testing those combinations into our objective function W weight produced weight values of 1652, 1033, 833, and 845. It looks like a winner chicken dinner was the 11 food bars and 1 drink carton combination, which produced the minimum weight of 833 grams. So that was the big winner. Although your astronaut might be a tad thirsty, right? Just kind of dry mouth. A lot of food bars and not many drink cartons, but that did minimize weight, and that was our objective. Awesome. What questions do you have about our activity 2 with the astronauts? So we've practiced our linear programming strategy a couple times now. We know that step 1 is to identify the variables. Write down what X and Y stand for. 2, we're going to write the constraints as a system of linear inequalities and write down an objective function. Next, we'll go ahead and graph those constraints, label the feasible region, and find the corners of that feasible region. Those are the vertices of my feasible region. We'll test those vertices or critical points in my objective function before finally stating our decision based on the results of that test, right? You guys have a somewhat self-directed review assignment in the sense that everybody's going to complete your linear programming worksheet number 3 and number 4. If you take a look at the back whiteboard, I've gone ahead and put those problems 1, 2, I included Mr. Santos, and the wired zones and unwired zones in case you wanted to check. And then also number 3 and number 4, which is your part of your assignment today, that includes a baking example with cakes and cookies. And I know we just had lunch, but gosh darn it, I'm hungry any time of the day, and so we'll stop talking about that now. And then you're going to go ahead and work on some book review. Everybody's going to complete these self-test items, the 1 through 7, 10 through 12, 13, A and B. Do all of the self-tests that we've selected here, and we printed this out on your note sheet so you don't have to copy this down hurriedly. We wrote it down on your, we included it on the printout. And then once you get to the chapter review exercises, where the asterisk is, now you're going to purposely select at least 2 from each objective based on your individual strengths and weaknesses and how you can best prepare and practice for your test. So you're going to choose, right, which problems you want to do out of these selected numbers. The assignment's going to be out of 33 for everybody, but I would encourage you to do more than 33. It's just that it'll be out of 33 for everybody when we do our check in the next class. And you want to make sure you're choosing problems that are appropriate for you. So you don't want to just pick the easiest ones or the quickest ones. You want to pick the ones that are going to give you the best practice and preparation leading up to the Unit 7 test. Does that make sense? We included this on a printout so you'll be able to refer to it later today. But first, we want to make sure that we have your Unit 7 stamp check outline. So we've got our Bellwork days 1 through 10 for a total of 10 possible red marks. We've got 3 different activity stamp places. Our first one was the bobbleheads. The bobbleheads with teachers and coaches. That was for 1 stamp. Then we had the mouse checks technology with the video games. And lastly, we had our astronaut problem that we just talked about for a total of 1, 4, and 4 is 9 blue activity stamps. 10 possible red marks for a total of 19. I'm going to put this back up, but first I just want to outline the test topics that we included on your test printout. for today's notes. You can go through and see exactly what skills and tasks you'll be assessed on in tomorrow's test. And then I also included these answers not only taped to the back whiteboard, but also I exported these as part of our notes PDF. So on the Moodle site, just log in as a guest and you can access all the book answers. They're all there on the notes PDF. Does that make sense? So you'll be able to access that whether you're here in school or at home. You can just go to the Advanced Algebra Moodle and go to the bottom of the notes for today, day 10. Awesome. I'm going to go ahead and stop and save the recording. And I'm going to give you an opportunity to count up your stamps before coming around to check with you individually.